Okay, Miss Playluck here again. This is Flex A, solving quadratics. Got the accompanying worksheet. So this one is solved by completing the square. I picked a difficult problem so I can cover all of the pieces that you need to remember. If you have a leading coefficient of 1, you don't have to do the first step I'm about to do. When you complete the square, your leading coefficient on your squared term has to be 1. So in this case, it is not. So what I'm going to do is I'm going to divide everything by 4. So I'm going to divide every term by 4. So I get n squared plus 2n minus, I don't even know what this is, 77/4 equals 0. The next thing, I'm going to move the constant to the other side. So I'm going to leave the parts, the quadratic and the linear parts on one side and move the constant to the other. So I'm going to add 77/4 to both sides. Now if you already had a constant, you wouldn't have to do that. If you already had a leading coefficient of 1, you would have had to divide. But if this was your original, you would just move on to the next step. Okay, so we have n squared plus 2n, and I'm going to leave a space here, equals 77/4. Now if you had a squared and a linear term and a number on the other side, that's where you would start. The completing the square part comes in where you take the b value, or your leading coefficient on your linear term, and you divide that by 2. So 2 divided by, positive 2 divided by 2 equals 1. And then you take that number and you square it. So 1 squared is just 1. And then you add that to both sides. So I'm going to add 1 here, and I'm going to add 1 there. The next step is to rewrite it in factored form, and notice that it's always going to be the square root of n squared, or square root of your square term. So if this is n squared, it's going to be n. If it's x squared, it'll be x. And then it's b over 2. That's why I always write it down on the side if you've noticed me doing that. So it's going to be n plus 1, that quantity squared, equals, now I'm going to simplify this here. 1 is the same thing as 4 over 4. So this is really 81 over 4. I got a common denominator. So now, at this point, I have a squared term, a squared quantity, equals a constant, and I'm just going to solve by taking square roots. So this is just like the top of the worksheet, except that instead of it just being a variable squared, it's a group squared. So I'm going to take the square root of both sides. Now don't forget, you have to consider both the positive and the negative. So on the left, the squared and the square root cross each other off. That's why I took the square root. And on the right, I'm going to have plus or minus the square root of 81 over 4. What's nice, 81 is a perfect square, 4 is a perfect square. So this really equals plus or minus 9 over 2. Okay? And now I have n plus 1 equals plus or minus 9 over 2. And I'm going to subtract 1. So I get n equals negative 1 plus or minus 9 halves. But this can be simplified. So I can do n equals negative 1 minus 9 halves. And that is the equivalent to negative 2 over 2 minus 9 halves. So that's negative 11 halves. And I could do n equals negative 1 plus 9 halves. So again, negative 2 over 2 plus 9 halves. And that would equal 7 halves. So my two solutions are n equals negative 11 halves or 7 halves. So when you have a plus or minus, especially if you have no radical left over, you want to write it as two equations so that you can figure out what your answer simplifies to. So n equals negative 11 halves and n equals 7 halves. So this is probably one of the more complicated problems. I had a fraction to deal with. I had to get common denominators to simplify, but the steps remain the same. Make sure you have a leading coefficient of 1, get the constant to a side, find what b over 2 is, because that's going to be in your factored form. You square it, you add that to both sides, and then you solve by taking square roots. That's completing the square.